Did you imagine one day hitting the lotto? How would it be? What will be the first thing that you will do with that money? Do you take a very nice trip to the place of your dreams, to the location of your dreams? Do you buy that expensive luxury super sports car that you always wanted? You get a house. But most important, you don't need to wake up and go to your day-to-day job. Have you ever wondered how life would be if you hit the lotto? Me too. Okay, this video we are going back to Earth, okay? It's great to dream, but it's better to be alive, okay? So, in this tutorial, what I'm going to be doing is that we are going to build the smart contract. We are going to finish the entire lottery smart contract because we need to move into the back end. I think the back end is going to be the biggest lift in this application. We have to grab all the information that we will obtain from the smart contract and build the application. In this case, build all the functions in the backend that is going to trigger every single function in a particular order. Listen to me carefully, in a particular order, in order for us to automate the entire app. Because the idea behind this lottery is to automate the opening and closings of every single draw, meaning that I'm going to start a new lotto draw. I'm going to let that draw run for a period of time. In this case, 24 hours. Let's say we're going to do a draw every 24 hours. And we'll have a timer that timer is going to keep counting until that time runs out. What's going to happen in the backend? The moment we run out of time, I have to send a request to the smart contract to close the draw. Okay, we have to close the draw. What we are going to do? Remember the last video? Chainlink VRF. We are sending that request to Chainlink VRF. Give us those random numbers. We'll calculate the percentage of the random numbers so then we can obtain the winning numbers, right? But we're not done yet. Now I need to grab the information from those winning numbers, or grab the winning numbers, and I have to determine if we have any winners, okay? Which means that I have to store every single ticket number that every single player has purchased on the platform, okay? Once I obtain that, I need to check or compare against the winning numbers to determine if we have any winners. And why is that? It is extremely important to determine if we have winners because number one, I need to determine how many people won the lotto or how many people got the same tickets or got the winning tickets, right? So then I can grab the entire jackpot balance and then divide that by the amount of winners so then I can distribute the price accordingly, okay? I gotta make sure that I can pay everyone equally, okay? Not only that, I need to make sure that draws or tickets from the previous draw are not used or are not claimed in the active draw. Meaning that if I roll draw number 8, okay, and I got 10 tickets in draw number 8 or 10 purchase tickets in draw number 8, we have to make sure that those tickets are not used in draw number 9, okay? Which means that I have to somehow relate the ticket numbers to the draw number. And for that, we are going to be building a very extensive struct to store all the values of the draw. Okay, we are going to get the first ticket number and the last ticket number for each draw. Okay, let's say so far we have sold over 2,000 lottery numbers. Then that means that the next draw I need to assign as the last ticket number to be 2,000, because remember, we sold 2,000 tickets already in the entire app. Across all my draws, I have a total of 2,000 tickets, which means I have to keep a count of those tickets. And then once I close every draw, I have to mark every single draw in the struct with the last ticket number along with the first ticket number that was sold, okay? Which means that the last ticket in the previous draw is going to be the first ticket. You know, we'll add the last ticket on the draw plus 1. that will be the first ticket ID in the sequence of draws, okay? So let's say the last ticket number was 2000. The next draw, the first ticket ID is going to be 2001, okay? We'll let the draw run, and then at the end, when we close the draw, we have to determine which one was the last ticket ID, okay? Once we get those two values stored in the struct, I am going to grab those two values, and then we will use those values to compare the winning numbers. Once I get those winning numbers, all I have to do is I have to say, does ticket ID number 2001 matches the winning numbers? No? Okay. 2002, 2003, all the way until we checked every single ticket ID that was sold in that particular draw. You see what I'm going? So I have to make sure that I keep an entry or a registry of every single number in every single draw. So that gives me not only the range of tickets, right? Or the amount of tickets that were sold in every particular draw, but it also gives me the first ticket ID that I need to check against the winning numbers, and the last ticket ID that I need to check in the winning numbers against the winning numbers. So that tells me what's the range that I gotta be verifying. And I make sure that I'm not gonna be checking it against ticket numbers that don't belong to that particular draw, okay? We need to make sure that obviously we store the user wallet associated to the ticket ID, because if there's a user that won the lotto, the user must claim the jackpot using their wallet address. And then I'm going to check in the smart contract if the wallet address matches the ticket number. Okay, so let's go ahead. Let's finish up the entire smart contract. Let's complete this entire phase and we'll move into the backend. Okay, let's go ahead and let's make this happen. Let's make this happen. Okay. One thing that I forgot to mention at the beginning of the video is that we need to integrate the ERC-20 token smart contract, because we want to charge every single ticket purchase using our custom ERC-20 token, okay? So what I'm going to do now, I am going to copy and paste a smart contract, a sample ERC-20 smart contract that I've been developing in this channel, okay? So let me go ahead and paste the smart contract right here. And it's very straightforward, right? So if you want to know more about the ERC-20 token smart contract, I have a couple of videos that are amazing and you can build this. It's very straightforward, okay? So to just go over it very quick, I have a smart contract that is going to provide up to 1 billion supply. So I have a 1 billion token supply in this smart contract, and this will be the token that we will accept as form of payment for every single ticket purchase, which means that I have to deploy this smart contract and I have to provide the smart contract address when we deploy the Lotto smart contract, okay? So let's make sure that we understand that, okay? Let's go ahead, and what I'm going to do now, I am going to start working on the smart contract where we left it off. So remember the last video that we did. The last video that I did, we completed the entire Chainlink VRF integration. Now we have to finish the entire smart contract. Every single function has to be implemented. So first thing we're going to go up to the top, and we have to import some additional dependencies. The dependencies that I'm going to be importing are going to implement reentrancy guard for security purposes. We are going to implement the ERC-20 token smart contract, and this will be the smart contract that we are going to use as our token smart contract. And lastly, we are going to implement safe math because we're going to be doing some calculations, and it's recommended to use that particular interface. We're going to be using safe math to do so. Okay, so let's go ahead and let's make this happen. So first, I'm going to grab the information that I need. I'm going to start copying and pasting. Okay, so I am going to add the safe ERC-20. This allows me to perform safe transfer. It's a recommended way of interacting or doing transactions with ERC-20 tokens. I am going to be using this particular import. I am going to also be importing reentrancy guard, as I mentioned. Okay, we're going to be doing that. I'm just going to throw it down here. And I am going to also integrate safe math, as I mentioned. So let me go ahead and add safe math. Cool. And finally, we have to work with the smart contract. This will be the ERC-20 token smart contract. This is the N2D rewards smart contract. And you can see here that I haven't appended the path because it's just going to be a local smart contract that we just deploy in Remix. So we'll have both in the same directory. So this smart contract is going to be able to find the other one. Okay. So we got this ready to go. This will be the smart contract. Now I can invoke the smart contract and interact with this smart contract in the Lotto smart contract. Okay, so now we are going to charge the ticket purchase using the custom ERC-20 token. Okay, so for this demonstration, what I'm going to do, I'm going to deploy this. We're going to deploy a brand new ERC-20 token smart contract. We'll get the address and we'll deploy this one as well. Okay, cool. So now I have to import the following. First of all, I have to declare that this also has reentrancy guard. So what I'm going to do, I'm going to press comma. I'm going to do reentrancy guard. There you go. And that should be it. Okay, cool. So that looks good. Now I am going to implement safe math for my integers. So we're going to be doing some math formulas. And I want to make sure that we're using this library right here, this import. And we are going to specify that we're going to be using safe ERC-20 for the token interaction, for the interface, for the ERC-20 interface. Okay, cool. Now I have to do the following. This particular section is very important. The first thing that I'm going to be declaring, as a matter of fact, I just started the smart contract here. I added all the initial dependencies right here. Now what I got to do, let me go down below the mapping. Okay, so this is where the chain link information ends as far as my declarations. Now what I have to do, I am going to specify that ERC-20, it's the pay token. Okay, so pay token is me doing a variable. I'm declaring this variable to be pay token, which means that when I deploy the smart contract, I am going to have the address of the smart contract associated to the pay token. Every time that I have to interact with that token smart contract, either I am going to be transferring from the smart contract to the wallet, I am going to be transferring the opposite. The user is going to be transferring to the smart contract. We will invoke this. Okay, so this is how I am going to associate safe ERC-20 to ERC-20, and then I'm going to associate ERC-20 to the pay token contract address. Okay, cool. Next thing that I have to do, I am going to be declaring the public variables. And please listen carefully and pay attention to this because this is the most important declarations in the entire contract. I am going to be declaring UINT256. This will be a public declaration and will be the current lottery ID. Okay, so what I'm going to do right here, I am going to keep track of every single lotto that has been opened, every single draw. This is the value that will increment. So if we close draw 1, we open 2, current lottery ID is going to be 2, draw 3, draw 4, draw 5, and we'll continue on until the application keeps running. Okay, so this is what's going to provide that, or it's going to append the value of the current draw. Okay, cool. Now I am going to declare UINT256, and this will be also public to the ticket IDs. Okay, so we are going to also declare public current ticket ID. Let me add this. There we go. Okay, which means that every single ticket purchase this value is going to increment. So if there's already 10 tickets sold across the entire smart contract age, or in this case, so let's say we have 10 tickets sold since the deployment of this smart contract, then the current ticket ID will be 10. Okay, so this will keep incrementing. Next, we are going to assign the ticket price to each lotto ticket. Okay, this is where you associate or you assign the price of the token. Okay, so in this case, this token, this ticket price is going to be the ticket price equals then the amount. We are going to charge 10 Ether. Okay, this is not like Ethereum or ETH. I am doing 10, and Ether is the measurement. So which means that 10 tokens. If my token smart contract is the N to the R, that's the symbol of the token, then I am specifying that every ticket purchase is going to cost 10 N to the Rs. Okay, so we got that. Now I'm going to do UINT256, and we are going to declare this a very important piece, because if you open this application and you deploy this and users are using it, what's the gain? What are you gaining in exchange? Okay, there should be some sort of profit, right? So what I'm going to do right now, I'm going to add the service fee. This is the amount that we will subtract from every single ticket purchased. We are going to subtract X amount, and that will be the fees that the contract will obtain as the service fee or the revenue for every single ticket price. So in this case, what I'm going to do, I am going to impose a service fee of 30% from the 10 Ether. From every ticket sale, we are going to get 3 Ether, or in this case, 3 N to the R tokens. Okay, you see? So that's kind of cool. Service fee is going to be 3,000 because this is basis point, which basically what it does is literally 30%. This is what I'm expecting, okay? And we are imposing that fee for every single ticket. So now that you know that, you should know that what gets accumulated in the pool, in the jackpot, it's going to be 7 tokens, okay? So we obtained 10. From those 10 we took out, we subtracted 3, which means that's our earnings for every sale. And then those 7 that are left, we just throw them inside the pool. So the jackpot pool keeps increasing, okay? So that's how we do it. That's very straightforward, okay? And I have to declare the number winner, okay? So this is literally me telling as public which ones are the current winner numbers, okay? So I am calling this because I want to make sure that this is public and we can get that information. We want to display this in the front end, okay? So that's why I'm doing that. I'm going to enumerate certain aspects of the activity in the draw. Let me explain to you. So when we enumerate, we are going to be enumerating an action. Is it open, is it closed, or is it claimable? Open means that the Lotto draw is open for ticket sales. Okay? If it's closed, the Lotto draw is closed, meaning that I'm not going to be able to buy any tickets for that particular draw. And claimable, the Lotto draw prize can be claimed. Okay? So what am I doing with this? What I'm actually doing is I am assigning claimable to the status of every single draw because I already got the winner numbers. I already checked who got the winning ticket, or if we had some winner tickets, or in this case, some players won the jackpot. I make sure that I did all that calculation so then I can declare the draw to be claimable. Okay? If the draw is declared to be closed, I am not going to allow anyone to cash out yet. I need to wait for that, okay? You're following me, okay? Cool. And this will be implemented in the Lotto Struct. Very important for you to understand the entire thing, okay? So this is how I can tell every single draw the status of it. I can say that it's open, it's closed. If it's open, then I'm going to say, if the draw is open, then you can buy tickets and so forth. If the draw is closed, you can no longer buy tickets. If the draw is claimable, if you want a prize, you can go ahead and claim it because I already went through the entire process of verifying the winner numbers, getting who got the prize, and so forth. Okay, cool, awesome. Now let's do the struct. Very important. This is like super important. Okay, so we are going to open the struct. First thing I'm going to do, I'm going to go ahead and copy and paste. So when I open the struct, I am going to be storing the following info. I am going to be storing status. Remember the enumeration, okay? And I'm going to say status, meaning that whatever the status is, I am going to be storing this inside the struct. Okay, so either open, close, or claimable. And you're going to see how I'm going to be able to assign the status. As I call certain functions, I am going to change the status. Okay, so and this lottery will be mapped to a particular draw ID. You're going to see that in a second. Okay. Cool. Okay, so this is done. Now I got to do the following. I'm going to say ERC-256. And this will be the start time. Okay, why we need to do start time, and also we need to do end time. Okay, very important. So every 24 hours, we're going to open a draw, and after 24 hours, we're going to close it. We want to make sure that we get the time when that draw was open, so then we can go ahead and avoid the draw from being closed accidentally. Meaning that if I have a function in the backend that is auto running, for some reason it crashed and you restart that service again, it's going to check, the smart contract is going to check if it's ready to close it. Because remember, that's going to run automatically. So we have to make sure that we have to prevent from closing it during the time period that it should not be closed. Okay, so we are going to grab both the start time and the end time. And we're going to say if the time is more than end time, that means that the Lotto draw has been closed. It already went through the end time duration. Okay, sweet. And this is where we are going to record the ticket ID. So every single ticket that gets purchased, we are going to record the ticket ID. And we mentioned at the beginning of the video, if I have 2,000 tickets, right? And that was the last ticket ID that was sold, 2,000, then the next draw, I am going to have 2001, 2002, 2003. And you see where I'm going. So this is how we store this. Why? Because once I get those both values and I subtract the last ticket ID against the first ticket ID, that gives me the amount of tickets that were sold in the Lotto draw. Duh. Okay, cool. ERC-256. And now what do you think I need to store? I am going to store transfer jackpot. Okay. What is this? Well, this is where the magic prize is stored. Okay. Meaning that this is where I am going to store in every draw the prize pool. So if there's 1,000 tokens as the jackpot for the particular draw, this is where I'm going to store that value. If there's a ticket purchase, I am going to be incrementing that transfer jackpot. So every time that someone buys a ticket for a particular draw, I am going to grab transfer jackpot and I am going to add 7, because remember, we are subtracting 30% from every single ticket purchase. If the ticket is 10 tokens, then I have to subtract 3. I'm left with 7. I am going to add 7 to the transfer jackpot. By default, I decided, and this can be done, you can get the smart contract, do whatever you want with it. I decided to open every single draw with 1,000 tokens. Okay, so every single draw is going to be open with 1,000 tokens. Okay, if this draw, let's say draw number 6, no one wins the pool, the jackpot, I am going to add this to the pool, the upcoming draw. So in this case, from draw 7. So now it should be 2,000 tokens, right? So it's going to be, every draw is going to have 1,000 tokens. The moment someone, claims the prize, then everything goes back to 1,000. If not, it keeps increasing. X, 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 X. It continues increasing on, okay? If there were 2 tickets sold in the first draw, guess what? This is going to be 1014. Remember? 7 from every single purchase ticket will go to the pool. We have 2 tickets, 14. So 1014. If no one wins this jackpot, I am going to transfer whatever I got from here, and I'm going to add another 1,000, right? Which means that, the next draw is going to be 2014, right? So we are going to keep increasing that pool. Okay, that's very important. Cool. So you got it so far. Awesome. Now what I got to do, I am going to store the last ticket ID. Or in this case, this was the last ticket that was purchased before closing the draw. Okay, so if we sold 10 tickets, The first ticket was 1, and then the last one was 10, okay? So that's how I know, right? And then we will get the total amount of tickets sold for every single draw. We have to store the winning numbers. Okay, so with the winning numbers, I am going to store which numbers were the winner numbers. When we do that entire Chainlink VRF calls, we get all that information from Chainlink. We'll just store the values for every draw here, and every draw will have the winning numbers, and then anyone can claim those earnings if they want the ticket later on. Okay, cool. So now what I'm going to do, I am going to also capture total payout. Okay, so what I need to do with this, what I'm going to do with total payout, it's if there were multiple winners, I am going to get this value and I will be dividing this value amongst all the tickets that won the jackpot. Okay, so basically this is what I'm going to do. And UINT 256, I am going to be storing the total commission amount. So from every single ticket purchase, let's go back up here, we are going to obtain 3 tokens. From 10, we will obtain 3. So what I'm going to do with that, I'm going to keep incrementing this, and this will be my commission. For every single draw, I'll have a commission. What I need to do at the end, the Lotto app, because it's obtaining all the ticket deposits. So what I want to do, every single ticket sale, the ERC-20 tokens are going to be transferred onto the smart contract. When I need to cash out, I need to withdraw that commission fee. I am going to have a function that will do the withdraw. And what it's going to do is going to check the struct, and it's going to say, well, you have this commission from this draw, okay? And you can go ahead and withdraw those funds, those earnings, okay? Cool. So we are there. This will be commission. Got it? And finally, I have to store the amount of winners. Meaning, again, if I have multiple tickets that got the jackpot, then I have to make sure that I'm going to divide the total payout against the winner count. So then I can distribute the price amongst the winners. Okay, cool. Now I'm going to build another struct. So struct, and this struct will be ticket. Okay. This struct, what it's going to do, it's going to store every single ticket purchase, meaning the numbers that the user selected as the ticket numbers, the wallet, and if the ticket is going to be claimable. Why? Because I'm going to be checking every single ticket against the winning numbers. And if there's a ticket that won the jackpot, I am going to declare this. I am going to mark it as claimable. Okay. Then once the user hits the claim function, it's going to check if the wallet has tickets that were prize tickets, were winner tickets. Okay. So that's how I'm going to be able to identify which wallet is a winner wallet. Okay. So what I'm going to do, I'm going to say UINT256, and we are going to say ticket ID. Okay. Then I am going to store, obviously, the wallet of the player, the owner wallet, in this case, the ticket or wallet. Okay. And finally, I am going to store the numbers. Okay. So the cells, every cell ticket, those are the numbers that the player selected, and we are going to be storing that inside the struct. Now let's do some mappings. All right, awesome. Okay, so the first mapping that I have to do, and if you don't know what mapping is, or you are not familiar with mapping, I have a very cool video. It's called What the Struct, or in this case, What Are Structs in Solidity? Allows me to do the storage of every single data in the smart contract and then relate that to a mapping so that I can find the information and access the information, okay? So in this case, I am going to create a mapping for lottery, okay? So this will be inside the struct, will be private because it's only going to be used inside the app. We're not going to let this be called from the outside. And let's say lotteries. What I'm going to do with this, every single draw is going to be the lottery ID, or in this case, the lottery. And then when I say, okay, give me the information for draw number 5, then what I pass here is a number 5. And in return, I should obtain all the information obtained for that particular draw. Okay, cool. And let's take advantage of the mappings here. I'm going to copy. I'm going to make another one. This one is going to be ticket. Okay, so this is going to be mapped against the second struct, which is going to be ticket. And we are going to say private tickets. Got it? Awesome. All right. Same thing, tickets against tickets. So in this case, what I'm going to do, I am going to be mapping the ticket number to the struct. So when the user buys a ticket, that ticket number, I can read the ticket information because I am going to call the struct by just referencing it to the mapping, okay? So this is basically referenced here. I am doing a nested mapping on this one. So what I'm going to be doing, I am going to be mapping the address of the wallet, map that to the ticket number, okay, or the ticket ID, which inside the ticket ID, we're going to hold all the ticket numbers, or the numbers that the user selected as the tickets when they purchased the tickets and they played the lotto, okay? What I'm going to do here, I'm going to be storing this in user ticket IDs per lottery ID. Okay, this reference is going to reference both the draw ID and the ticket ID. Okay, so the ticket ID is going to tell me that this ticket belongs to this draw. Okay, and what I'm going to do with this, it's for me to count the tickets, or in this case, to sort over every single ticket that was sold and compare that against the winning tickets. So you're going to see this later on the tutorial, so don't worry. Okay, and this one is pretty much self-explanatory. I'm going to show you this one. Okay, so this one, what it's going to do, it's going to store the amount of winners per lottery draw. So in this case, the lottery draw, the draw struct, I am going to be storing in this mapping the address, the wallet address that is a winner wallet address. Okay, so then I can show this information on the application. You can see here I declared this as public. So that allows me to show who won. If this wallet was, won the jackpot in this particular draw ID, I am going to be able to display this here. So I'm going to use this mapping to declare that and be able to find that information. You got it? Awesome. And finally, we have to do some events because we want to track the activity in the smart contract. Events are a very cool way to find information and do some auditing. Like in case we need to obtain information about a particular transaction, if we declare events, we can obtain that and we can record that action, that transaction. Okay, so you want to make sure that you do that. So I'm gonna declare, let me just copy two at a time. So then we go over it very quick. Okay, so the first one is going to be the lottery winner number. When I obtain the numbers from chaining BRF, I am going to be declaring this event. And what I'm going to do, I am going to attach the draw ID and the winner numbers. It's just an event, so then I can go back, and if I want to search for that particular event, I'm going to obtain the winner numbers. Very simple. It's very simple. And it's very handy. It's very useful, okay? Then the next one, let me just add this up here, the lottery close. So again, let me generate an event where I closed the draw number X, and this was the last ticket ID in that event. So I know that that was the last draw, and this was the last tickets that got purchased. Okay, so the last ticket that got sold in that particular draw, I'm just going to declare that in the event. And now let me take an opportunity. I'm going to paste the two events, which are basically the same as the struct. All I'm going to be doing, very simple. I am going to be storing the lottery ID, start and end time, ticket price, first time, transfer jackpot, last time, and the last ticket ID and the total payout. This is for me, every time that I open a new draw, I am just going to create an event. And again, this is not mandatory. However, it's very handy because you want to make sure that you obtain that information in case you need to do some auditing to the smart contract, and I got to get that information. I have an event, okay? So I can go back in the event and get that information easier, okay? I am going to store the ticket purchase. So every single ticket that gets sold, I am going to declare an event for that. So then I can go back and, hey, I can do some auditing. I can do some accounting, like make sure that you have a way to do that easier, okay? And here's the fun part, okay? So what I'm going to do now, I am going to be declaring in the constructor. So once I deploy the smart contract, I am going to ask for the pay token smart contract address. And we have to make sure that we declare as during the deployment, so that I'm going to be using that to make calls to the token smart contract, okay? So with that said, I am going to create the constructor for that. I'm going to say ERC-20, and we will call this pay token. Okay, remember that was the variable that we declared, but then this is basically the placeholder for that. And I am going to say, remember up here, I'm going to show you right here, pay token, right? So what I'm going to do now, I am going to say that the pay token smart contract is this right here. I'm going to say equals to what? To this right here, okay? Kind of cool, huh? Awesome. So that's all we're going to be doing. We're adding the token smart contract in the constructor, so then we add the token smart contract to the deployment. When we deploy the Lotto, we have the token smart contract already deployed or associated or bind it into that smart contract. Got it? Cool. Now, what I have to do, I have to open the Lotto draw. Once we open the Lotto draw, we are going to store every single attribute inside the struct. Okay, so remember the struct that we built? We are not going to start storing data onto it. Okay, let's do it. Let's build that function. Okay, so let's go. Let's do it. Here we go. This is our magic function right here. Well, every single function is magic, but this one is special. Okay, what the hell am I doing here? I am basically creating a function to open every single draw. Okay, this will be only called by the owner of the smart contract. Okay, and this will be a non-reentrant, meaning that only one time can be called. So what I'm going to do now, I am going to declare all the information in order for me to open the draw. Okay, only the owner of the smart contract can open this particular function, or can call to open draws. Okay, the moment I open a draw, what do you think is going to happen? I got to increment the lottery ID. Draw 1, draw 2, draw 3, draw 4. So this is holding that value, and I am basically increasing this by 1 every time that this function gets executed. Now, remember at the beginning of the video when I explained the ticket numbers, when we open every draw, remember the last ticket ID plus 1 will be the new ticket ID. Okay, so what I'm going to do, I am going to be increasing that by 1 as well. The current ticket ID was the last ticket ID plus 1. Now I have to make sure that I provide that token prize or the jackpot to the draw. And you remember how did I mention that we were going to do that? What I'm going to do, I am going to declare a variable called fun jackpot. I'm going to do an integer var that's going to be fun jackpot. That basically what it's going to do is going to store inside the lottery struct. I am going to be storing transfer jackpot by adding 1,000 ether. So every time that I open a lottery, the current lottery ID, what's the current lottery ID? Let's say I just deployed the smart contract. This is the first smart contract that I deployed. Lottery ID number 1. Remember, if started with 0, but then I added 1, and then I am adding this here. Okay, so in this case, before passing through this, it was lottery ID 0. Now it's going to be Lotto 1. So what I'm going to do, I am storing inside the struct for draw number 1, current lottery ID, I am storing 1,000 tokens. In this case, this will be the jackpot. I am funding it that way. And I'm declaring this to be a variable because we're going to be using that as well. Okay. Now I am going to be declaring the transfer jackpot so then I can store values inside there. I need to make sure that I declare those variables so then I can use them in the struct. I am going to be passing data to that struct. Now let's open the struct, right? And let's add the information inside the struct and check this out. Status. We open the status. Basically, the draw has been open. We are going to change that enumerate into open. So we are going to change the status into open. That tells me the draw has been open, okay? We are going to declare the start time and we're going to be using block timestamp. The moment we open the draw, we are going to capture that block timestamp and we will store that in start time. End time, very important. How do we determine the end time? Let's say we want to do 24 hours. Every draw will be every 24 hours, which means that I have to store the start time and add 1 day. And this is how we do it. We basically call block timestamp.add. This is a safe math function, and we will just say 1 day. That's basically adding the end time. So with this value, I can tell that the backend cannot close the draw if this value is not over the current block timestamp, meaning that if the time hasn't reached this value, then I am not going to allow you to close the draw. This is another mechanism that we are going to implement to protect the draw from being closed. Now, the ticket ID, we are going to store the current ticket ID. We mentioned that the current ticket ID, we are going to add 1. That was the last ticket ID plus 1, the new current ID, okay? The transfer jackpot, this is the prize pool. In the draw, we are just funding it with this particular variable that calls basically this. We're just going to add 1,000 ether. And you might say why you had to call this struct value before. Okay. Why am I doing this if I just need to add 1,000 ether? You wonder why. If the previous draw, no one got the jackpot, I still have the balance of the previous draw here. What I'm going to do, I'm going to pass that into here. I'm going to add new tokens. I'm going to add an extra 1,000 tokens. That's why we're doing it. Okay. This is how I'm able to pass the jackpot from the previous draw if no one took the prize and move it to the new draw. I'm just going to add whatever I got left from the previous jackpot and add 1,000 tokens, and this will be the new jackpot. Okay. If someone, got the last jackpot, someone, took the prize pool, then this will be 0. I'm just adding 1,000 tokens. You see what I'm going? Awesome. All right. And obviously the winning numbers. So when we obtain the numbers from Chainlink, we do the math. We will store every single number in this particular array. This will be the winning numbers. And we're going to use this to validate that we got some winners, okay? And the last ticket ID will be the same value as the first ticket ID, because remember what I need to do, I have to increment this every time that someone buys a ticket. The last ticket ID will be incremented, okay? So you are going to see that. And the total payout, we are initializing this with 0. So the moment the draw closes, I am going to be passing the total payout. In this case, the amount that every single holder or every single player will receive. They won the lotto, okay? You see what I'm going? So this is different from here, because you might say, well, why you need to store it again? No, let's say we have 3 winners, okay? So what I'm going to do in the math of the draw, if I had 3 winners, I am going to divide the value times 3. So if we have a pool of 3,000 tokens as the jackpot, I am going to divide that amount against 3, or in this case 3. And what I'm going to add here is going to be the individual amount that each winner is going to receive. See what I'm going? Why I'm doing this? Because the moment the user claims, I already got the amount that I have to pay the user. I have to pay to the winner. You see where I'm going? So I am actually giving the individual amount that I have to issue as the payout. Let's say only one won the pool, then it's going to be the entire balance. Okay, so I'm just going to divide that by 1, which is literally only 1. Okay, cool. The commission is every single ticket sale we mentioned. We are going to store the commission right here. And how many winners do we have? Those two values, winner count and total payout, if we multiply this with this, we should get the entire jackpot fund. Okay, so we will get the total amount. And now I am going to add an emit. So I'm going to emit an event, because remember we configure those events. So every time that we open a draw, we want to emit an event that says lottery open, and we're just going to pass all those values. And you can see the values up here. This will be the event right here. Okay, and it's self-explanatory. It's basically what we already discussed. Okay, cool. And this is how we open a draw. This is literally what we need to do to open a draw. Okay. Now let's build the function to buy tickets. Let's do it. So to buy tickets, I am going to obtain from the user the following. Okay, what I'm going to pass. Check this out. What I'm going to be passing under buy tickets is going to be the numbers that the user selected. Okay, so it's going to be a public declaration. It's going to be payable. So it's a public function, payable because I am expecting some payment for every ticket purchase. In this case, the 10 tokens, okay? And it's gonna be non-reentrant. Okay, let's break this down. So first of all, I have to make sure that the user has money in their wallet. So if the user doesn't have the tokens to buy the ticket, I'm just gonna stop the transaction. So how am I going to do that? I am going to create a var called wallet balance, and I'm going to obtain the balance of the user who called the buy tickets function. So in this case, I am going to make sure that this user, whoever is calling this function, has the balance necessary to buy a ticket. And or else I'm going to stop the transaction from happening. Security, again, security mechanisms, very important. And then I am going to send that requirement. I am going to specify that requirement. If the wallet balance, what we declared previously, it's more than the ticket price, then go ahead and continue. Else, your funds are not available to complete the transaction. That's how we do that security mechanism. Okay, so we are going to make sure that the user has the custom tokens. Else, we're not going to allow the user to buy the ticket. And then we will go ahead and do the transaction. So what I'm going to expect from the user, I'm going to be calling the function from the ERC-20 token smart contract. Remember, we are integrating the ERC-20 so then we can interact with that contract. And we are going to call the transfer from. I am going to specify from the message that sender to this address. This will be the Lotto smart contract. So I am obtaining those N2DRs, and we're going to store those N2DR tokens on the Lotto smart contract, okay? And what I'm going to pass, hey, send me this amount, which is the ticket price. The ticket price, we already mentioned that it was right here. Here we go, 10 tokens, okay? So you got to send me 10 N2DRs. Let's continue here. Now let's apply the tax, okay? So what I'm going to do for the tax, I am going to declare another var, commission fee. I'm going to be declaring commission fee. And what I'm going to do, I am going to obtain the tax fee, or in this case, the transaction fee. This is what we are going to earn as the platform developers, or in this case, as the owners of the application. So what I want to do, I'll multiply ticket price, multiply that by service fee. Remember service fee, that is the 3,000 basis points, which is 30%. Then divide that by 10,000. That basically converts this value into the commission fee, and this is the amount of tokens that I'm going to receive. This right here, this formula should give us 3 tokens, basically 3 tokens, okay? So this is how you obtain or you apply that tax fee, okay? And now we are effectively storing that tax fee here, okay? Every time, check this out, every time someone buys a ticket, from the price that they paid, we are going to keep adding the commission fee. Remember, we already are going to have a balance in the commission fee. So every time that there's a ticket, let's say someone bought a ticket, this entire value inside the struct is going to be 3. If someone buys a ticket, then that means I'm going to add 3 again. So this will now be 6, and then we'll go 9, and then we'll go, and we keep incrementing. So what I'm doing, I'm adding this to this existing. I am not replacing it. That's why I'm doing plus equals. Okay, so what I'm going to do, I'm going to add what's already existing plus this. This is how we are just going to increment that. Okay, now I need to make sure that I pass the difference from the ticket sale onto the pool. So what I'm going to do, I am going to be declaring net earn. So net earn is going to be the ticket price minus the commission fee. That's it. So this value will be 7. If the ticket is worth 10 tokens, then the ticket price minus commission fee should give us 7. So this will be the balance that I'm going to be passing on to the jackpot. So the jackpot is going to keep increasing. As people buy tickets, we are going to be increasing the jackpot by 7. Okay. And I effectively continue adding onto the jackpot the balance of the amount of tickets sold, or in this case, the pool, okay? So the current jackpot, let's say we already have 2,000 tokens in the jackpot. I am going to be adding, every time that someone buys a ticket, I am going to be adding 7 more, okay? So this is literally 2007, 2014, and continues. Every ticket sell will add 7 onto the pot. Now I have to store the ticket numbers that the user bought into the struct, so then we can use those values to check and confirm that the user has winning numbers, right? So we have to store the numbers and map those numbers against tickets that were sold, okay? So what I'm going to do here, I am going to be storing that in the user ticket IDs. So I am going to show you, by the way, let me go ahead and break this down. Let me do this, right? So this will be the commission section, and then what's left will be transferred to the Jackpot. Now, every time that the user buys a ticket, the message to the sender is on this mapping right here, user ticket IDs per lottery ID, message sender, current lottery ID. This is the current draw. I am going to be pushing what? The current ticket ID, okay? Current ticket ID, what's the current ticket ID? The ticket number, okay? The purchase ticket ID, okay? And now I have to do the following. Why am I doing this? Because this allows me to reference the ticket number to the wallet. So who owns the ticket number, to which wallet, and which draw is that ticket number belonging to? That's a nested mapping that we definitely want to take advantage of. Now, I'm going to show you this. This is a little bit more extensive, but it's very similar. Now, what I'm going to do, I'm going to store tickets under the ticket struct. I am going to call that by draw ID, I am going to call this by ticket ID, okay? And inside the ticket ID on the struct, what I'm going to store. Let me go ahead and press enter so then it's not all like tied down so you can understand this better. What I'm going to be storing here, right? I am going to open the struct, reference to the ticket number, and inside the ticket number, what I'm going to be referring, the ticket number, and I'm going to store the wallet of the owner of that ticket that got purchased and the numbers. Okay, we are going to be storing the numbers that the user selected under that struct so then we can find information in case we need to, pay the user, okay? And once the transaction is done, I gotta make sure that I increment the current ticket ID. So then the next player will have the next ticket ID, okay? And we are going to go ahead and lotteries, okay? We are going to now add the last ticket ID. So the last ticket that was sold in the draw, I am going to update that to be the current ticket ID, okay? You see where I'm going? So now we know that the current ticket ID is the last ticket ID that was bought. When we call that function, we are going to keep incrementing this, okay? And finally, I'll just do an event, like someone bought a ticket. Simple. I'm gonna say emit, tickets purchased, match the sender, current lottery ID and numbers. And you can go to the event. Here we go. Message sender will be the buyer, lottery ID, and then the numbers. Simple, okay? We're done. We are almost done here. Okay. Now let's close the lottery. And the lottery, when we closed the lottery on the last video, what we did was just the Chainlink VRF integration. And you see, there's a lot to do here. And that's why I'm doing it, because I want to make sure that I'm not going to cram the entire topic into one video because there's a lot, okay? So now what I have to do, I am going to be adding a couple of requirements. The first requirement that I'm going to be doing is that I'm going to make sure that if the backend is trying to close the Lotto, I have to make sure that this Lotto is still open so that I can close it. You see where I'm going? Like I have to make sure that the Lotto is open. I cannot close something that is already closed. I have to make sure that the Lotto is open, or else I'm not going to let you. If the Lotto is claimable, I'm not going to let you close it because it's a different status. It's not open. Okay, so that's why I'm doing it that way. Now, I am going to grab the following. I am going to say, very important, if the block timestamp, this is the current time. If someone hits, in this case, it's only going to be the backend, but if someone hits this function and the block timestamp, the current time in the blockchain, is more than the end time, the time that we have stored here to be this, if it's more, that means that you can go ahead and close the Lotto because we already ran out of time. Else, the Lotto is not over. Okay? There you go. Awesome. And now we want to make sure that we finally dictate that the last ticket ID was the current ticket ID to make sure that we are effectively setting that as the last ticket ID. So we are just making sure that case, and we are officially closing the draw. What I'm going to do, I am going to change the status from open here to close. We are changing that effectively now. Okay. Then once we do that, when we are going to proceed with the Chainlink VRF, okay? And once we're done with that, all this was discussed in the last video. Once I am done and I obtain those winning numbers, what I'm going to do, I am going to emit that event that the Lotto got closed, okay? We closed the Lotto, we're done, okay? There you go. And that is the closed lottery. We are effectively checking those two values and doing that update, getting the winning numbers, and off we go. Okay? Now, we're getting to more fun stuff here. Okay? Check this out. I am going to be drawing the numbers. Okay? So in this case, I named this to be get winning numbers, but in this case, let's make it draw numbers. Okay? Meaning that this is the function that is going to get that winning number. So we are going to apply that percentage to the random number that we obtained from Chainlink VRF, okay? And before I do that, I have to specify a requirement. I have to make sure that the Lotto is closed, okay? So that status has to be closed, else I am not going to continue, okay? So unless the draw is closed, else I'm not gonna let you run the draw numbers, okay? So I have to make sure that I change that beforehand. Okay, so now what I have to do, I have to make sure that, I obtain those numbers, and this will be, quote, the winning numbers, okay? This is looking good. One thing that I want to add to the function, there's cases where the number might be 0. If you want to allow 0 to be a number that could be draw and could be a winning number, fine. In my case, I don't want 0 to be a number. Let's say if it randomly selects a 0 based on this math formula right here, I want to convert that to 1, okay? And that also tells you that 1 will be a number that you can play because there's a high chance, it could happen, it cannot happen, but I don't want to see 0 in the winning numbers. Okay, so what I want to do, I want to check every number. If there's a 0 in one of those numbers, 1, 2, 3, 4, 5, 6, as the value, I am going to add 1. So I don't want to see 0, okay? So what I want to do instead here, check this out. I am going to add a for loop. Basically, we are storing all the numbers, all the entire number array. After we obtain those numbers, we store that under final numbers, and then I'm going to say, right, I am going to take out return because we don't want to return. Instead, we want to now find if there is a number that is equal to 0 here. If either one of those is 0, I want you to convert that to 1. You see what I'm going, okay? So no longer we'll have 0 as a number in the winning numbers, okay? And what we are going to do, we're just going to obtain the struct. We're going to be adding the winning numbers, okay? Boom, we added the winning numbers. Winning numbers in the struct will be the final numbers. That's it. And we have effectively transferred the prize pool as the jackpot. Okay, so now the total payout will be the transfer jackpot. We are transferring that as the total payout, so then I can grab that value and divide that by the amount of winners. Simple, okay? Now, if I had 3 winners, I am going to divide the transfer jackpot amongst the 3 winners, okay? So I can pay equally. And we are done with that. Okay, now we're getting to the point of counting the winners. Before counting the winners, you remember that bubble sort? This is the moment where we are going to be sorting the array. We are going to add a function that is only going to be called if I need to sort the winning numbers, okay? Listen to me carefully. I am going to be sorting only the winning numbers because the tickets, every ticket that we purchase, will be sorted outside of the smart contract, so we save on gas fees. We're not going to be spending a lot of gas fees just by sorting every single ticket number that was purchased, right? We are doing that off-chain. The only one that we are doing on-chain will be the winning numbers. Else, it's just going to be done off-chain, okay? So let me paste this entire bubble sort function, right? But this entire bubble sort function is literally the same function that we covered on the last video. The only difference has been adapted to Solidity. I'm going to go over it very quick. The function is called sort arrays. I'm passing all the winning numbers. It's going to be an internal function, meaning that I'm going to be using that in another function to just pass the values and do the math or do the formula, okay? It's going to be pure, and it's going to return, what am I going to be returning? Memory, okay? So I'm going to be returning array in order, okay? The winning numbers in order, okay? And basically the same thing. I covered this in the last video, literally the same thing. I am, grabbing one value, flipping it over which one is lower and so forth, and I'm changing the state of this Boolean from swap to be true, and else just return the numbers. If everything got swapped, give me the numbers, and then at the end, just return me the numbers. This is literally the same function that we covered in the last video, okay? And finally, we're almost, I'm going to tell you right now. There's quite a few functions, but this one, it's going to be the longest. I think the last one that it's going to involve a lot of explanations. Again, you want to have a full-blown game winning, running out of a smart contract. This is how we do it. There's a lot to be coding here, okay? But again, you want to be a master in blockchain, this is how we do it, okay? Count winner, let's start counting the winners, okay? We are going to be passing an array, right? And I'm going to also pass the draw ID, okay? This will be only called by the owner of the smart contract. I am going to require that the lottery is already closed before I can move and call this function, okay? Make sure that you understand that. That status must be closed, and the status cannot be claimable, meaning that I haven't already done this function. When I finish this function, I am going to say that the status is claimable. I'm going to change this status from closed to be claimable, okay? That tells me that if this is not here, if this status is not set, that means that we haven't run this function yet, okay? Now there's a public var called number winner that I am just going to delete the value because I'm using that value to do my math, and you're going to see that in a second. This is a public number or a public var that I have to make sure. This is a public declaration that I have to make sure that I just wipe out and reuse it again. Okay, so every time I don't want to leave that, with data, okay? Because they could change the result. And now I'm going to be passing the first ticket ID as well as the last ticket ID. I am passing those two values. I am passing the first ticket ID and the last ticket ID because we have to be identifying the amount, the times that I have to be checking every single number, okay? Or every single ticket against the winning numbers, okay? Now we are going to create an array, an empty array, because we have to pass the winning numbers inside this array so that we can sort them in order. I am going to be effectively passing the array, which, by the way, this is the winning numbers. I am going to be passing the winning numbers to this function, which is sort array. That will be the bubble sort. This moment, I am effectively sending that to the bubble sort. We will put those numbers in order, and we will store that in win order, which is the empty array that I created previously. There you go. You want to be a blockchain developer? This is it. Okay, now, here's the fun part. We are going to be encrypting in KEYCAC256. Effectively, we will hash this array, this entire array of winning numbers into KEYCAC256. Awesome. Okay. The moment we do that, now we have this to compare against every ticket that was sold. Okay. Cool. Now, what I have to determine, what's the first ticket ID? Okay, so I have to make sure that I store this in I. Okay, so the first ticket ID will be I because I am going to be doing that for loop, and we are going to be checking every single number or every single ticket against the winning tickets or the winning numbers. Now let's build that for loop. Okay, for I, the first ticket ID, I must be less than last ticket ID, which we are also passing here. Then I'm just going to continue. So if the first ticket ID was 2001 and the last ticket ID was 9 because we sold 9 tickets, then I'm going to run this for loop 9 times. That will allow me to check the 9 tickets against the winning tickets. And now I am effectively getting every single ticket info, the owner and the ticket numbers, and I'm going to be encrypting them in KEYCAC256 as well, so then we don't have to do a manual sort and verifying that every number matches, okay? And check this out. I am going to be pasting the entire thing right here. I am going to say number, user number. This is the ticket number of the player. Those are the ticket numbers, okay? I am going to store that in an empty array called user num, and then I'm going to grab that and encrypt them or hash them in KEYCAC256. Check this out. This is where we identify if there is a number or if there's a ticket that is a winning ticket. If encode user, meaning the user tickets encoded or hashed in KEYCAC256 are equal to encode win, which is the winning numbers, ding, 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 we got a winner, okay? Number winner, we are going to increment that count by 1. We will store the number winner in the winner count. And now we will declare that buyer in the winners per lottery mapping, okay? That's the mapping that is going to store every winner from every draw. So we are storing the buyer address. Remember, we grab the buyer's wallet address. We're passing it to this mapping along with the draw ID, and we are going to set that value to 1. What am I doing with this? What I'm doing is, if when the user wants to claim the prize, if the user, when they hit the claim button, if they have 1, meaning when they pass those values, right, the Lotto ID and the buyer into this mapping, right, and the mapping returns 1, that means that you're a winner. Else, you're not a winner, which means that I'm not going to pay you. Okay, so this is what I'm doing to identify if that wallet is a winner wallet, and I'm going to pay that user. And then we're going to finally close the for loop. Okay, so I have to close. This is the if condition. I'm going to close the for loop right now. And now, if there is no winners, that means that winner number stayed in 0. Remember, we deleted the winner number, so it became 0. If there was no increment of number winner, that means that there were no winners in the draw, which means that I have to do the following. I am going to say number winner, okay? And check this out. Number winner is 0. That means no one won the jackpot. So what I'm going to do, I am going to increment the jackpot for the next draw. So this is effectively me passing the jackpot to the next draw, okay? So now the current lottery ID, I want you to add 1, which will be the next lottery ID. And now in the next lottery ID struct, I am going to be transferring the jackpot. Okay, and what's the jackpot? The current total payout. Simple. So that's how we do it. If there were no winners, I'm just going to pass the entire jackpot to the next draw. Okay, and now we are going to finally declare the draw to be claimable. We already went through every single check, and we made sure that the users that won the lotto, they can claim their prizes. Okay, and with that, I have to build the claim price function, and we're done. We're almost done. 3 more functions, and we're done. Okay, so now what I'm going to do, I am going to claim the price, and let's just paste this entire thing because it's going to be very quick. Okay, what am I going to do when I build the function to claim the price? I am going to say Lotto ID. Okay, Lotto ID. Then I am going to require that the status is claimable, meaning that I already executed this entire function. Else, I am not going to allow this to be run or to be executed, okay? Now I have to make sure that the winner count, remember that's another value inside the struct, is higher than 0. Else, do not let this run, okay? There has to be a winner. And now finally, I am going to check if the player that is claiming this function or is calling this function to check if they have a prize, if they won the lotto, I am going to make sure that the Lotto ID and the claimable status is 1. Remember when we said that right here? This is where we said that a user was a winner of the draw by just putting 1 as the value, okay? So if you have 1, when I check your wallet against the Lotto draw, if it returns 1, that means that you won. Else, I'm not paying you and I'm stopping, okay? And now effectively winners, remember, if I have multiple winners, I have to make sure that I can pay everyone, right? So what I'm going to do, I am going to store winners in the amount of winners for this draw. And then the payout, what I'm going to do, I am going to divide the total payout against all the winners so that I can pay one by one. and am effectively transferring the tokens to message.sender. So I am going to be transferring the payout amount, right? This right here, this is the amount that the winner got here. So I'm going to be transferring that to the winner from the smart contract. So I have to make sure that the smart contract is funded. Okay, so if there's not enough funds, I cannot pass that. I cannot pay the player, the winner. Okay, so I have to make sure that the contract is funded. I'm going to show you how we're going to do that. It's very simple. What I need to do, very important, because if we don't do this, the user can go ahead and claim again. Okay, so once I pay, I have to make sure that I change that value from 1. Remember when we said that the user won to 0, which means that the user no longer has the prize. I already paid the user. Okay. And that's how we do the claim. It's very, very straightforward. You can see that right here, okay? And we got a couple of functions and we're done, okay? And we can test the smart contract. Oh, those are the chain link functions, okay? So I'm not gonna mess with them. Those are functions that we covered in the last video. Now what I'm going to pass certain functions, and those are functions to view tickets and view stuff. So I'm going to show you how they work, okay? So I'm going to be passing view tickets. So view tickets, what I'm going to do, is going to allow the user to check their ticket numbers. Okay, so you just need to know what the ticket ID is, and you just pass that, and I am going to give you the ticket numbers. Okay, I am going to also declare a public function here to view the lottery. Okay, so what I'm going to do, I am going to allow to show that publicly. You know, I just passed the Lotto ID, and I should obtain every single value inside the struct. That's how we're doing. We're just passing the entire lottery struct in memory and return it right here, okay? And now I have another function that it's only callable by the owner of the smart contract. This function is going to provide the owner of the smart contract the balance of the tokens inside the smart contract, inside the Lotto smart contract. So the platform knows how many tokens do they have so they can pay the price, you know, the pool, okay? So we have to make sure that we have that. And this is the information that we will display in the front end, but it will be in the Lotto admin portal. So in the Lotto admin portal, I'm going to show the balance in the smart contract. So then we know that the contract has sufficient funds to pay the price, okay? And now I am going to do a function. Let's say that the smart contract doesn't have enough funds. So I did another function that will allow me to just deposit into the tokens or the custom ERC-20 tokens inside the smart contract. So if the smart contract is running low on funds, I can fund it with this function, which is basically just calling safe transfer from, you know, the message.sender to the smart contract and the amount that I'm passing, which is basically me, you know, sending that information out, okay? And the last function, withdraw, okay? So we're done. And how do we withdraw? Basically, if I want to withdraw the tokens out of the smart contract, I am just going to call this withdraw function. And basically what it does, it sends to message.sender, but only the owner of the smart contract can call it. I am going to just pass the entire balance of the smart contract address to the message.sender. And that's it. We're done. Now let's go ahead and test the smart contract. Now let's go ahead and test. Let's finally test it out. So what I'm going to do first, I am going to copy the token smart contract. Let's deploy the token smart contract so then we can deploy the Lotto smart contract. So what I'm going to do, I'm going to grab this, I'm going to copy, I'm going to go ahead and paste, okay? And let me go ahead, and I just did 2 files. So I have one file n2d-lotto.sol, and I got n2d-rewards.sol. Okay, so I am going to Control S, compile successfully. Awesome. Let's go ahead and deploy that. Okay, and make sure that I got the wallet. Okay, perfect. I got the right wallet. Cool. And let me go ahead and deploy it. Awesome. Let's wait for that, and then we'll deploy the Lotto smart contract. Boom, we got the token smart contract. Cool, awesome. Let's do the following. I am going to add the token smart contract in the list of tokens, so then we can mint some N2DRs, right? So I don't have any N2DRs, so let me mint a couple so we know that we have tokens, right? So we are going to have tokens in the wallet. So let me open the smart contract and let me go ahead and mint. I'm going to mint, and this will be in way. So what I'm going to do, I want to mint 10,000. Let's mint 10,000. So 10, 1, 2, 3. And we need to add 18 zeros. So then we convert this to way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Awesome. So we got 10,000. And by the way, I put that in the wallet address. So no, it's not there. It's the amount that's here. But now let me provide my wallet. And let me just copy this. This is my wallet. I'm going to send it right here. And we are going to approve. And now, once I get approved, I should see my tokens. So let's see if we get those 10,000 right here. And wait for that. Boom, we got 10,000 tokens. Awesome. All right, we're good on the token smart contract. Now I am going to deploy the Lotto smart contract. Okay, so let me go ahead and copy it. Control S. Boom, just pasted the smart contract. Cool, awesome. One thing that I'm going to do, you saw in the struct, I added the end time. What I'm going to do, I am going to change this to be a number that is like 100. Why? Because I want to make sure that I can close the Lotto. I don't have to wait 24 hours to test the smart contract, right? We want to do the entire process. I'm even going to bypass the winning number so that I can provide the winning number so then we can see that we will obtain the jackpot if we do get the right winning numbers, okay? So what I'm going to do, delete this entry. I'm going to delete this entry right here and time, like just say 100. Right? We know that this will be obviously lower than the block timestamp, so that will allow me to close the draw anytime. But remember, the right syntax will be block timestamp, and then we will add 1 days. Okay, so that adds 24 hours to the draw. Okay, but for now, what I'm going to do, I'm just going to type 100 so that I can close it at any moment. Okay, that's it. I'm going to Control S. Make sure that it compiles successfully. Beautiful. Awesome. So now I have to deploy the smart contract. So what I'm going to do, you can see already it's asking me for the pay token as well as the subscription ID, because remember when we wrote this smart contract, let's see where the constructor is. We were asking for that. Okay, so we got it right here, ERC-20 pay token. Okay, so let me provide the into the rewards smart contract address, and we have to find the VRF subscription ID. Remember the last video? We are going to obtain that from our subscription 3531. Okay, Control S. Sorry, Control V, and yeah, let me transact, and we will deploy the into the Lotto smart contract. Beautiful. We are waiting for confirmation, and boom, we have confirmation. We should have the token smart contract and the Lotto smart contract. Awesome, awesome. All right, let's have some fun. Okay. So we have all the functions. So the first thing that I'm going to do, I am going to open a new draw. If you see right here, the current lottery draw, there's 0. There's no Lotto draws open. No ticket numbers have been generated or tickets purchased. Get balance. Oh, you know what? Let's do the following. What I'm going to do, remember, if anyone wins the Lotto, I have to provide the jackpot, right? So the jackpot is going to be provided from the smart contract. I should have funds in the smart contract to pay the jackpot. In this case, we're going to be paying with the N2the tokens, okay? So what I have to do here, I have to provide the balance. I have to deposit tokens onto the balance. So what I want to do, from my wallet, I am going to transfer onto the smart contract, okay? So we have the interface because we invoked the ERC-20, so we should be able to receive the tokens right here. So what I'm going to do, I'm going to copy the Lotto smart contract address. I'm going to go to my MetaMask. Let me go to the assets and the N2the I'm going to send some tokens to the smart contract, okay? So I'm going to paste the smart contract Lotto smart contract address, and we already can send the amount. So what I'm going to do, I'm going to say 5,000. I'm going to say 5,000 N2the tokens, and we are going to say next. And this moment, I am sending 5,000 N2the tokens to the Lotto smart contract. Okay, just wait for confirmation. Confirm. Awesome. Now let's see the balance. There you go. We got 5,000 N2the tokens in the smart contract. So if there is a jackpot that is less than this, we should be able to pay it. Okay. Now, awesome. So now, yeah, let's open a Lotto. So we're just going to invoke the open lottery. Remember, the owner wallet is the only wallet that can open the Lotto. Okay, so we're just going to do that. And we are going to confirm. Boom. And we have opened the first draw. Okay, let's take a look at the information. Current lottery, draw number 1. So this is our first one. There's no tickets sold. So we are starting with ticket ID number 1. So remember, every time that we open a draw, we're going to increment the count by 1. But this ticket hasn't been sold yet, okay? Awesome. So let's go down. And if we open the view lottery, because this is a public mapping, so I am just going to label this 1. I'm going to say call. And let's take a look at the information that we get. The first value, if we go into the struct, it's the status. The first in the enumeration in this section, which is status enumerate, open is 0, close is 1, and claimable is 2. So right now, that I'm going to zoom in so you can all see completely, okay? So you can see 0, it's basically open. So this lottery ID has been open. If I go to number 2, and obviously there's nothing, but again, this is not open, okay? So let me go back. Okay, Lotto 1. And then now I have the start time. So the start time is block timestamp. This is the block timestamp. The end time, remember we changed that to 100 so then we can close the draw right away. And then the first ticket ID, we can see the first ticket ID to be 1, right? The transfer jackpot, here we go. So we have issued a initial jackpot amount of 1,000 tokens. So this is the amount in way. So the moment someone buys a ticket, they should increment to 1,007 because that's the amount that will be allocated from the 10 tokens, right? So the other 3 will be for the commission, okay? And now the last ticket ID, remember the first and last ticket IDs will be the same. The only one that is going to change is the last. Every time that someone buys a ticket, we'll increment this, okay? And now all 6 values right here are the winning numbers. So when we get a winning number, this will be populated with the amount or with the values, okay? And then we'll get the commission. Oh, this is the total payout, right? So you can see here, I'm following the order. Total payout is this one right here. And then we got commission, how much you earn in commissions. And then finally, how many winners in this particular draw. Okay, cool. So let's buy a ticket, okay? Very important because I am going to be paying with the custom ERC-20 token. I have to approve the Lotto from transferring those tokens from my wallet. So I have to send an approval to move 10 tokens, okay? So that I have to tell the ERC-20 smart contract, hey, approve this particular address to transfer those funds or else it's not going to pass. So what I'm going to do, I'm going to copy, make sure that you know this. If we don't do that, we're just going to get an error. It's not going to let us, okay? So let me go to entity reward. Oh, also another thing that I forgot. I have to add this as a consumer in Chainlink. Else we're not going to get any winning numbers. We're not going to get the random numbers. So I want to copy, I want to go to the description, and I'm going to add a consumer. And we're going to go ahead and paste. Very important. I forget this one. And I'm going to confirm, and now we should be good. So let's see right here. Now let's wait until it gets confirmed, and we can go from there. Consumer added. Awesome. So, okay. So now we're good there. Now I want to buy a ticket. So what I have to do first, I have to make sure that the Lotto smart contract has approval to move the funds from my wallet. So what I'm going to go to my token smart contract, and I'm going to say the spender is going to be the Lotto smart contract. And the amount that I'm going to allow it to spend from my wallet is, let's just put a number. In this case, I can just fill this with zeros. But in the backend, you're going to see that I'm going to only approve the amount that we need to buy a ticket. So in this case, 10 tokens, okay? So the end user must approve that first. So we're going to transact. And now it's just going to ask, permission to access your entity-Rs. And I'm going to say, yes, confirm. Boom. Awesome. Got confirmed. Beautiful. We should be able to buy a ticket. Okay, so you can see the approval here. Now I'm going to go to the lottery and I am going to buy a ticket. So what I have to do, I have to provide this in an array order. So what I'm going to do, I am going to type 4, 10, 7, 9 or 8. I'm going to say 2 and I'm going to say 14. Okay, so those are my numbers that I selected. Let me buy that ticket. Boom. And we have bought the ticket. I'm going to buy another one. Okay, so I got confirmation. We can see the confirmation. Now we are going to just change this to be 8, to be 2, 9, 12, 1. Okay, I'm going to transact this one. Confirm. Boom. I got the second ticket. Okay, so let's take a look at some information here. Let's see the current ticket ID. Current ticket ID is number 3. Why? Because I bought 1 and 2. So now the next ticket ID will be 3. The moment someone buys the ticket, it's going to be ticket ID number 3. Cool. Now I have to also identify the following. I am going to find here right now, we can see that the first ticket ID, this is going to be after end time, which we set manually to be 100. Then the ticket ID is going to be first and then the last. Let me take a look now. Now the difference is, by the way, you see now the jackpot. What's the jackpot? Now it's 14. Why? Because I bought 2 tickets. All right. So I want to show you the last ticket ID. What's the last ticket ID? It's 3. First ticket ID is 1. So we know that 1 and 2 will be counted as tickets for this draw. Okay. And then 14, remember, we set a commission of 30%. So from 10 tokens, 7 will be allocated to the jackpot. So from every single ticket sale, those are 10 tokens. I am going to grab 7 will be allocated for the jackpot. We'll just drop that in the jackpot. And then 3 will be the commission earned for that sale. If you see here, it's 6, right? We sold 2 tickets, 3 and 3, 6. Okay, so we are getting the commission stored in the smart and the Struct for the draw, and we're getting also the jackpot incrementing. Beautiful. Okay, so we set, we know that everything is working 100%. Now I have to another thing that I want to see. Okay, let me see the tickets. Okay, let me see ticket ID number 1. I'm going to call that. And you can see the numbers that I got, the numbers that I bought, and this is the owner or the buyer for that ticket. Okay, that's the wallet. Okay, now we are going to see ticket ID number 2. That's the second ticket number or the ticket that I bought. So the same owner. Okay, now let's close the draw. Okay, but in order for me to close the draw, like I told you, I had to change the end time to be 100 so that I can close it without waiting 24 hours. Okay, so when I just close, I'm going to confirm. And we're almost done. Everything is great when you're just testing, everything works, but you don't know what the hell I had to go through to make this happen. But that's why we're here. We're here to learn. If everything is easy, everyone will do it. Okay. So with that said, okay, the Lotto has been closed. Now let's see more information, right? What we are going to see now, now we have the status changed to 1. 1 is closed. Remember, 0 is open, 1 is closed, and then 2 is claimable. Beautiful. So now we know that this draw, no one can buy tickets on this draw. Okay. So with that said, now I have to draw the numbers. Oh, by the way, closed lottery means that I called the chaining VRF and I got the random number. So if I go under get request status, those are my random numbers. Now I should be able to generate the winner numbers, which will be generated when we execute draw numbers, which is the next function after closing. Okay, so let's run draw numbers. We're going to run draw numbers, and now we should obtain the winning numbers. Let's wait for that. Boom. And I think we got confirmation. Beautiful. Now if I go back to the struct of the Lotto ID, now we should see this with the winning numbers. Okay, let's call that. There you go. Let's see what we got. We got 5, 5, 1, 9, 8, 9. So there seems to be an issue with the calculation. I have to check that one out. So then it looks more random because this is not as random as I want it to, okay? Now, what happens is the following. Now I have to verify, now that I have the winning numbers, right? Now I have to verify if there were winners, okay? So for that, there's another function. Remember that we coded that function in the smart contract, which is going to be count winners, okay? So when we run that function, right, we are going to know if there were winners or not. And we can tell there were not because no one, I didn't bought those tickets. So here's the thing. What I ended up doing here, for me to test, so I can validate that it's going to work, I can pass the winning numbers manually. This function, what we're going to do once we are ready to go, like, we have the backend running, everything, then this function, instead of being passed manually so that I can populate the fields with the winning numbers, I need to pass that inside the function, so then it just uses the numbers from Chainlink. We should not be able to bypass this. I am doing it because I want to test to make sure that it works, right? So in that case, what I'm going to do, I'm just going to pass the winning numbers because I want to show you, if there's no winners, what's going to happen. Okay, so in this case, I am just going to copy this, 551999. I'm going to copy that. And we are going to pass that as the array. Okay, cool. And now I am going to say Lotto ID 1 because that's the draw number 1, and we're going to count winners on that draw. Okay, so I'm going to run that. So what's going to happen now, guess what? It's going to do the bubble sort, and this should go in order. It should be sorted in order, and it should be encrypted in KeyCap 256. The same goes with every single ticket that we sold. Okay, so we're doing that right now. Okay. Boom, and we got confirmation, count winners. Now, if we go number of winners, 0. There's no winners, okay? And then let me take a look here. And you can see now that the status has changed to claimable, meaning that now this draw is claimable. Like, players can claim if they won the Lotto, they can go ahead and claim their winnings, right? So we changed that to claimable, which is number 2, okay? Beautiful. Okay. Now we know that no one got the jackpot. What do we expect? We expect that the jackpot should be transferred to the second draw, meaning that now, remember, every time that I open a draw, it's going to deposit 1,000 tokens, but now we're going to add this as well. So let me go ahead and open draw number 2. And then this time, we are going to manually buy a winning ticket. So you can see that we can get the jackpot, okay? So now when I open the next draw, which is going to be 2, we'll check again, and this should show me 2014 because it's adding the jackpot from the previous draw, okay? So let me go now, open the Lotto. I'm going to confirm, confirming, and we're done, okay? We're just going to do a mock test that we got the jackpot, okay? Beautiful. Okay, so the Lotto has been opened, the second draw. So let me now check lottery ID number 2 and see if this is 2000. There we go, 2014. Awesome. So now we transfer that jackpot to the next draw. No one has won the jackpot. And now you can see that the first ticket ID is going to be 4 and the last ticket ID is 4. This is the one that is going to increment, okay? Beautiful. Okay, so now what I need to do, I am going to buy tickets, okay? So let me buy this same one, right? And this will be for draw number 2. I'm going to confirm. Okay, so I got the ticket. Beautiful. Let me buy another ticket, and this will be, let me just change this to be 2. No, let me do this more different here. And 3, and 6, and 14. Beautiful. So I'm going to buy that ticket. Bought that ticket. Let's wait, okay? Now let's take a look and see how much has incremented. Now, because there was 14, now we should have 2028, okay? So let me go back and take a look here, 2028. And now you see that in this particular draw, we have a commission of 6,000, okay? Sorry, we have a commission of 6 tokens because those 2 tickets were purchased in this lotto. Okay, if I buy another one, increments to 9. Okay, cool. So now let's close the draw. Okay, we're going to close the lottery. When that happens, it's going to reach out to Chainlink VRF. And I'm going to show you. Let's wait for that to close. This one is going to take a little bit more time to close because it's going actually to execute that to Chainlink. Okay, so it closed. Let me go to the subscription. Now let me refresh, see if there's something pending here. And I think I already got it. Let's see. Yeah, I think it did. Okay. March 13. Yeah, it did. Okay, awesome. Okay, cool. So now if I check here, we should have different numbers. Let's see. Boom, we got different numbers. So we got the random numbers from Chainlink. Now let's draw the numbers, okay? I'm gonna draw the numbers, but in this time, after I draw the numbers, I know that we are going to get the numbers here, right? Boom, draws has been completed, call, and those are the winning numbers. So we got 2028, okay? So that's the amount in the jackpot. Now what I have to do to make sure that I am going to get the a ticket that is with a prize, I have to pass the win numbers as the same as this number. So what I'm going to do first, I have to make sure that I manually sort that because we're going to be sorting the user numbers outside of the smart contract, right? So in this case, I'm just going to simulate that I sorted those, right? So I want to make sure that I put them in order. So this will be here, and that looks good, okay? Awesome. So now they're in order, right? So I'm going to do here, I am going to buy this. Oh, you know what? I messed up. I should bought this in order because I am not going to be able to pass that in order, okay? Ooh, okay, so let me do it again. I'm just gonna do this. Yeah, I screw up. I should buy the tickets in order because I am not gonna be able to sort them right here, right? I'm gonna be doing it off chain, so don't worry. It happens. No worries, no problem. Okay, opening now the jackpot is gonna be higher, so it's gonna be like 3,028, right? So let me check again. And view lottery. So let me take a look at view lottery number 3. And yeah, it incremented to 3,000. Okay, awesome. Even better, we get more. Awesome. Okay, so cool. Let me now buy this ticket, which is in order, right? 2, 3, 6, 7, 8, 14. I'm gonna transact. I'm gonna copy this. I'm gonna pass this as winners, but I'm not gonna do it now. Just wanna make sure that I just have it here. So I'm gonna change this so I can buy another ticket. Okay, cool. Now, what I'm gonna do, I am gonna close the draw. And now that I got 2 additional tickets purchased, they should increment also to 32 or 42. Yep, yeah, 3,042 tokens. Okay, cool. Now, with that said, I am going to close the draw. And we are going to draw the numbers. Get that from Chainlink. Okay, we close the draw. Boom. Now I got to make sure that the request is there. It hasn't come up. And again, in the backend, I am going to have like a timer to have enough time so then we can get those numbers before, right? It's going to take a little bit of time. There we go. We got them. Awesome. Now we are drawing the numbers. So then it generates those numbers. Once it generates the number, we should see the numbers in draw number 3. And then now what we're going to do, we're going to count the winners, but instead we're going to pass this array as the winning numbers. So then we get the prize, okay? Draw numbers and ticket, lottery ID number 3, right? Okay, we got the winner tickets. And this is literally a very, well, this definitely got random. Okay, so yeah, this is something weird, but this actually got random numbers. Awesome. So now let me do the magic. So what I do now, I got a ticket that I bought that has those numbers. I'm going to pass those as the winning number so then we get the jackpot. Okay. Lotto ID number 3. Okay. Number 3. And we're going to send those numbers as the winning numbers. Beautiful. Now that I counted the tickets, we should have one ticket that was that got the prize. Okay, that was a winning ticket. So we have an entry here, number winner. Look at that. 1. So there's one ticket that is the winning ticket. So if we go in my ticket numbers, I think this is going to be ticket number 4, 5, no, 6, 7, and yeah, that's ticket ID number 7. Okay, awesome. So now that it got the tickets, now I can claim. So all I have to do as the player, I have to just pass the draw, which is going to be in the front end. We're going to pass that value, which is going to be lottery draw number 3. So I want to show you, once I send that, I want to make sure first, how many tokens do I have? 4,940, okay? If I hit here, we should get, what's the jackpot? 3,042 additional into the ERC because that's the jackpot, okay? So let me then claim the prize. I'm going to pass number 3. And we're going to say transact. There he goes. If we didn't have a prize, we will say we will have an error, okay? Claim, and let's see if we get 3,000 and something. 3,042. There he goes. Boom! We got the jackpot. Awesome, awesome, awesome. There you have it. We tested the smart contract. We know that it works 100%. On the next video, what we're going to do is we are going to build the backend. Get ready. It's going to be a wild ride. There you go. We are done with the Lotto smart contract. Now, listen to me carefully. On the next video, we are building the backend. Fasten your seatbelts on that one because that one is extensive and it's intense. We are automating the entire application with this one. The backend, the moment the backend runs, it's going to open the draw, it's going to close the draw, it's going to draw the numbers, it's going to fetch the winning numbers, it's going to tell the smart contract to run basically every single function. A lot of functions are going to be executed from the backend. I think the majority of the functions are going to be executed using the backend, okay? If you manage to master this particular development of the entire application and automating the smart contract calls and all that, you're on a very good position, okay? Alrighty, so that's it for this video. I hope that you enjoy this tutorial, and if you do, hey, subscribe, hit the thumbs up, and we'll see you on the next video. Bye.